the answers to the quiz questions on electromagnetic induction. The transformer has 60 turns on primary, 300 on the secondary. 120 volt applied to the primary. What's the voltage in the secondary? Vs by Vp is Ns by Np. So find the voltage in the secondary as 600 volt. A 4 millihenry coil carries a current 5 ampere. How much energy is stored in the coil's magnetic field? The energy stored in a coil is given by the formula 1/2 Li squared. So 1/2 times the inductance in henries, so it should be 4 times 10 to the negative 3 times 5 squared, which gives 50 times 10 to the negative 3 joules, which is 50 millijoules. And here we need to reduce the primary voltage of 120 to 6 volt. What's the turns ratio? Turns ratio is actually defined as the ratio of the number of turns in the primary to the number of turns in the secondary. So turns ratio is Np by Ns. And we know this is the formula for the transformer. So when you divide, Np by Ns should be the reciprocal of that, so which is 120 by 6, and therefore the ratio is 20:1. A 10 ohm resistor is connected to a 120 volt AC power supply. What is the peak current? Now remember that when nothing is mentioned about the voltage, that should be the RMS voltage. So first we can find the peak voltage by multiplying the RMS with square root of 2, and then find the peak by dividing this voltage by the resistance. 16.97 ampere, which is rounded off to 17 ampere. What is the reactance of a 1 millihenry inductor at 60 hertz? Inductive reactance is 2 pi times F times the inductance. So 2 pi times 60 times 1 millihenry is 10 to the negative 3. That gives 0.38 ohms. What size capacitor must be placed in series with a 30 ohm resistor and 40 millihenry coil if the resonant frequency is to be 1000 hertz? The resonant frequency does not depend on the resistance. It only depends on the capacitance and the inductance, and that's the formula for resonant frequency. Square both sides and rearrange to make C the subject, and then substitute the values. (40 millihenry), that's why it's 40 times 10 to the negative 3. And F squared is 10 to the 6. You get 0.63 microfarad. The flux through a coil changes from 4 times 10 to the negative 5 to 5 times 10 to the negative 5 in 0.1 seconds. What is the EMF induced? Induced EMF is the change in flux divided by time. Now the change in flux is the difference between the fluxes, and so divide that by 0.1 to get 1 times 10 to the negative 4 volt. What is the total impedance? And this is an LCR circuit, so you have all the 3 components. To find the total impedance, let's first find the inductive reactance, 2 pi f times the inductance. There's 188.5, and then xc, 106.1 ohms. So the difference between the two, 82.4 ohms, and then impedance is square root r squared plus xl minus xc whole squared. Substitute the numbers and get 129.6 ohms. Once again, this is an LCR circuit and you have to find the RMS current. Of course, to find the RMS current, we need the RMS voltage divided by the impedance. So we need to find the impedance again, just like in the previous problem. Find XL, find XC, get the difference between them. So the difference is 131.9 minus 265.3. And then find the impedance. Like in the previous question. Know that negative squared becomes positive, so IRMS is VRMS by Z. That gives 0.72 ampere. What is the inductive reactance of a 2.50 millihenry coil at 1000 Hertz? Direct question, just an application of this formula. (15.7 ohms). Well, the output of a generator is 440 volt at 20 ampere. It is to be transmitted on a line with a resistance of 0.60 ohms. To what voltage must it be stepped up if the power loss is not to exceed 0.010% of the original power? Okay, so first let's find the original power. Power is given by the product of voltage and current. So 440 times 20 gives the original power. And then take 0.01% of that, which is that divided by 100 times 8800, which gives 0.88 volt ampere or watts. Now power wasted is given by I squared R. So since we have I squared R, we can, and we know the resistance is 0.6 ohms, we can find the current. That is the current in the secondary. And for a transformer, when you take the ratio of the voltages, that becomes equal to the inverse ratio of the currents. Knowing all of the terms now, you can find Vs. You get it as 7.27 kilovolt. Here it is what capacitance is needed in series with a 30 ohm resistor at 1 kilohertz for a total impedance of 45 ohms. So this is an RC circuit and the impedance is given by square root R squared plus XC squared. So we can find XC now. Remember that XC is 1 by 2 pi FC. We'll get to that equation in a minute. But from the first equation, we can find XC by rearranging and taking the square root. So XC is 33.54 ohm. Now from this equation, capacitance is 1 by 2 pi FXC. F is 1 kilohertz, that's why it's 10 to the 3. And we get 4.7 times 10 to the negative 6 farad, which is 4.7 microfarad. Again, a question regarding a generator produces 60 amperes of current at 120 volt. Voltage is stepped up to 4500 and the line resistance is 1 ohm. We've got to find the percentage power lost. So we need to find the initial power and the final power. The initial power or the input power is product of voltage and current. It gives 7200 watts or 7200 volt ampere. And then this is the transformer equation. From which we find IS is 1.6 ampere, and therefore the power wasted is the square of this current multiplied by the resistance. That's 2.56 watts. Now, percentage power wasted is 2.56 divided by the original times 100. So 0.036% is lost. Notice that that's just a very small percentage of waste, and that is because the voltage was stepped all the way up from 120 volt to 4500 volt. What current flows in a 60 millihenry inductor when 120 volt at frequency 20 kilohertz is applied? We have to find the current here. And current is voltage divided by impedance. So first find the impedance, which is the inductive reactance in this case. And substitution gives 7539.8 ohm. And current is just voltage divided by the inductive reactance. That's 15.9 milliampere. And the last one, the cross-sectional area of the loop is reduced from 1 to 0.5 meters squared in 0.1 seconds. What's the EMF induced if B is 2 Tesla upward? Okay, according to the Faraday's law of electromagnetic induction, induced EMF is del phi by delta T, but magnetic flux is the dot product of B and A, which is BA cos theta. In this case, theta is 0 degrees. Do remember that theta is always taken between the magnetic field and the perpendicular drawn to the plane. That's why it's 0 degrees. Therefore, phi is BA. Substitute that into this equation. B is a constant, so it's taken out, and you have B delta A by delta T, which is delta A is the change in area now. So that gives 10 volt. Thank you. Study using this for the exam wherever you are, and please remember to like the videos there so that more and more students may be benefited. Thank you.